Hello again, guys. This is the continuation of what I've done in the previous video where I was discussing basics of electric circuits. So in this video I'm going to do calculations. So the example here says, in this circuit the battery has an EMF of 24 volts and internal resistance of 2 ohms. Ignore resistor of wires and ammeter. So it means that our wires and ammeter, they do not have resistance. Okay, so let us try to analyze our circuit before going to questions. So as all of you guys can see that we have our resistors that are in parallel combination with each other. So it means that this side we have a parallel circuit, and then we have the 8 ohms resistor which is in series with our batteries or our cells. So it means that it is the combination of a parallel circuit and a series circuit. Okay, and then we have the switch S here. So our switch S here is still open. Okay, so when the switch is open like this, it means that this voltmeter 1, because of it is connected across our 8 ohm resistor that is in series, it is going to measure the total EMF or the total voltage of our circuit. It means that V1 is going to read 24 volts, and then V2 is going to read 0. Why? Because of there's no current that is going to flow since all our switch is open. Okay, so this V2, it is connected across our parallel resistor, so it is going to measure the voltage here, here and here. Okay, so now let's go to questions. Number A says, calculate total resistance when switch S is closed. So it means that now we close switch S. So when we close switch S, the EMF is going to change. We are going to have what we call a V load. Now the V load, it is also known as V external, the external voltage, the voltage of our external circuit. Because of this is what we call the external circuit. So this is what is known as the external circuit. Okay, because of we have external resistors. We also have the internal resistor of our battery. So the battery has resistor also, which is known as the internal resistance or the internal resistor. Okay, so we want to know what is the total resistance when switch S is closed. Okay, so number A. So every time total resistance of a circuit is the same as the resistor that is in series plus the resistor that is in parallel. So it means that we are going to combine this resistor plus these resistors to get the total resistance of our circuit. So already we have the resistor that is in series, which is 8 ohms, and also the resistors that are in parallel, which are these ones. So I'm going to substitute what I have. RT is equals to RS is 8 plus RP. So RP we have to find it, since well there is a formula used to calculate RP that I've done in the previous video. So in order for us to get RP, we're going to say 1 over RP is equals to 1 over resistor 1 plus 1 over resistor 2 plus 1 over resistor 3, and then 1 over RP is equals to 1 over resistor 1, you can say is 3 ohms plus 1 over 9 ohms plus 1 over 18 ohms. So you're going to get 1 over RP is the same as, I think it's 1 over 2. Let me confirm. 1 over 1 over 3 plus 1 over 9 plus 1 over 18. So we get, it's half. So we get 1 over 2. So since we want RP, we're going to introduce minus 2 at the top like this. This is the reciprocal or the opposite. Then we get 2 ohms. You can also check it. Say answer which is 1 over 2, and then introduce minus 1 at the top, you must get 2. That's why we have 2 ohms here. Okay, so now it means that we have gotten our RP, which is the resistor in parallel combination. You're just going to substitute here. Okay, so when you substitute it, you're going to have our total is the same as 8 plus 2 ohms. Therefore our RT is equals to 10 ohms. Okay, so I hope you guys have understood what I've done there. It was quite easy. Okay, so let me try to do number B. So I'm going to try and create the space for number B. So I'm going to erase what I have done there. You guys can pause the video and analyze if you didn't understand, because of I'm about to erase. Okay, so for number B, we have to calculate the current flowing through the 8 ohm resistor when switch is closed. Okay, so as all of you guys can see that the 8 ohm resistor, it is in series with the cells. It means that the current that is going to flow in this resistor, it is the same as the total current of the circuit. Why? Because of the current when flowing, it won't be splitting like in these resistors. For example, in this resistor, when the current comes, it's going to split to the side, to the side, to the side, and then after that combine or merge in this point, and then come as a full current that is going to pass through the 8 ohm. So it means that if we can get the total current of the circuit, is that we have found the current that can pass through the 8 ohm resistor. Okay, so it means that R total is the same as V total over R total. This is what we call Ohm's law. You guys know this law, that the current is always the same as the volumeter at constant temperature. Okay, so we already know what this resistor is 8 ohms. But then before we can get the total current, we must firstly find the total resistor, meaning the total resistance of this circuit. We must know what it is, meaning we have to combine all of these resistors if we can include it here. So RT is going to be the same as 10 ohm. So this 10 ohm is this 10 ohm of this resistor and this resistor, and then we must combine it with the internal resistor, okay, plus 2, which is the same as 12 ohms. Okay, we already know what is the total voltage of our circuit, which is the EMF already. Okay, so therefore it means that our total current in the circuit is going to be the same as 24 volts divided by this 12 ohms. So it means that the current of the circuit is 2 amperes. Okay, So that therefore the current of the 8 ohm resistor is 2 amperes. Okay, I hope you guys have understood what I've done here. I'll do more other questions or examples involving this circuit so that you can be able to understand further. Thank you.